In level 3, we will be evaluating trig functions all over the coordinate plane when you're given a point. And we're going to do this kind of using our right triangle trig skills. So if you have an ordered pair that is on the terminal side of an angle, and we're trying to evaluate the 6 trig functions for that angle, what you're going to do is draw a right triangle formed by the terminal side and the x-axis. So it will actually have the reference angle as one of its angles. So I have a right triangle. The y value of this right triangle is 4. The x value is -3 because the coordinate is negative, so it goes in the negative direction. And then to find the r value, I'm going to use the Pythagorean theorem. And with the Pythagorean theorem, I don't really need to worry about negative numbers because the r is always going to come out positive, because 4 squared plus -3 squared equals r squared. I'm trying to find r, the hypotenuse. That's actually a Pythagorean triple. It's a 3, 4, 5, so that radius is going to be 5. And then all I have to do is, for sine, which is the sine of an angle, and again, we're referring to the reference angle, not the original angle. The sine of an angle is opposite over hypotenuse, which is going to be the y value over the r. So sine of theta is going to be 4/5. Cosine theta, which is adjacent over hypotenuse, would be -3/5. You need to take the signs into account. Sometimes they come out negative. The tangent of theta is opposite over adjacent, or y over x, which is 4/-3. Cosecant of theta is r over y, or the reciprocal of sine theta. So if I took my sine theta and then flip it, you get cosecant theta. So that would be 5/4. Secant theta is the reciprocal of cosine theta, which is -5/3. And then cotangent theta is the reciprocal of tangent theta, x over y, which is -3/4. And there are my 6 trig functions. In this next example, we don't have a nice, pretty Pythagorean triple, so the numbers aren't going to be quite as pretty, but we do the same thing. We draw a right triangle using the reference angle as our acute angle, and the y value is going to be -3. Since it's below, it has a negative y value. The x value is +6. And then we need to find r using the Pythagorean theorem. So -3 squared plus 6 squared, that's 9 plus 36 equals r squared, which is 45. And then r would be the square root of 45, which is, in simplified radical form, 3/5. So we get 3/5 for our radius, which again is always positive. And then for sine theta, I would do, from this reference angle, opposite over hypotenuse, or y over r, which is -3/3/5. But we want to simplify. We don't want to leave radicals in the denominator. The 3's cancel, and I multiply by radical 5/radical 5, and we get -radical 5/5. For cosine theta, we do x over r, or adjacent over hypotenuse, 6/3/5. the 3 and the 6 will become a 2 over 1. And again, I need to multiply by radical 5 over radical 5. We get 2 radical 5 over 5. And then for tangent theta, I do y over x, or opposite over adjacent, which is negative 3 over 6. That reduces to negative 1/2. And then cosecant theta would be y over, instead of y over r, I do r over y. So 3 radical 5 over negative 3, which is, the 3's cancel, negative radical 5. Secant theta is going to be r over x, 3 radical 5 over 6, which simplifies to radical 5 over 2. And cotangent theta would be x over y, which is 6 over negative 3, which is negative 2. And again, tangent and cotangent are reciprocals, cosine and secant are reciprocals, sine and cosecant are reciprocals. In the next examples, we are practicing figuring out which quadrant you're dealing with based on different signs. Cosine of an angle, that's always x over r. If this is greater than 0, r is always positive, so x must also be positive. So that would have to be, for x to be positive, either quadrant 1 or quadrant 4. Those are the two quadrants with positive x values. Now, if cotangent is negative, that means x over y is negative. We already know x is positive, so y must be negative. That means it has to be in quadrant 4. Okay, in this next example, same idea. Secant is positive. Secant is r over x. R is always positive, so x must also be positive for secant to be positive. So again, we're either in quadrant 1 or quadrant 4. And this time it says sine is positive. Sine is y over r. And if it's positive, the radius is, or the r is always positive. So y must also be positive. If you have a positive x and a positive y, you must be in quadrant 1. Now we're going to find the value of specific trig functions based on some information. So we're going to draw a coordinate plane, and we have to figure out where the angle is first. So we want to find sine theta and tangent theta if cosine theta is 2/3 and cotangent theta is greater than 0. First we need to figure out which quadrant we're working in. If cosine, which is, remember cosine is x over r, if that is a positive number, which it is, it's positive 2/3, we're either in quadrant 1 or quadrant 4. But it also tells us that cotangent is positive. Cotangent is x over y. We already know x is positive, so y must also be positive, which means we're in quadrant 1. So I'm going to draw my angle with its terminal side in quadrant 1. And I'm going to draw a right triangle in here. And if cosine, which is x over r, is 2 over 3, I'm going to make my x 2 and my r 3, which is the hypotenuse. And I need to find the y value. So I'm going to use the Pythagorean theorem. 2 squared plus y squared equals 3 squared. And we get 4 plus y squared equals 9. Y squared equals 5. So y would have to be the square root of 5. And now we want to find sine theta and tangent theta. So sine theta is y over r, which is radical 5 over 3. And tangent theta is y over x, which is radical 5 over 2. Same thing for the next example. First we need to figure out which quadrant we're dealing with. We want to find secant theta and tangent theta. If sine theta is 1/2, so that means y over r is positive, which means we have a positive y value. Remember, r is always positive, so we're either in quadrant 1 or quadrant 2. Those are the places with positive y values. And then we learn that cotangent is negative. So x over y is negative. That means we must have a negative x value, which means we're in quadrant 2. So we want to draw an angle that terminates in quadrant 2. So my angle might look like that. But the triangle we're going to use is with the reference angle, so the angle made with the x-axis, and sine of theta is 1/2, so that means that's y over r. Y is 1, r is 2, and then we have to find x using Pythagorean theorem. So x squared plus 1 squared equals 2 squared. X squared plus 1 equals 4. X squared equals 3. X equals the square root of 3. And it's going to be the negative square root of 3 because of its position. It's in quadrant 2 where we have a negative x value. Now I want to find secant theta, which is r over x. So that would be 2 over negative radical 3, but I don't want to leave a radical 3 in the bottom, so I multiply by radical 3 over radical 3, and we get negative 2 radical 3 over 3, and then we need tangent theta, which is y over x, and that would be 1 over negative radical 3, again multiply by radical 3 over radical 3, and we get negative radical 3 over 3. And here are two more examples. So for this part C, we want sine theta and tangent theta. Secant theta is 3. We want this to be a fraction, so we know what, remember secant is r over x, so we want that to be 3 over 1. That tells us we have a positive x value, because r is always positive, so it's either in quadrant 1 or quadrant 4, that's where we have positive x values. And then sine theta is greater than 0, that means y over r is greater than 0, or we have a positive y value. So we must be in quadrant 1 if both x and y are positive numbers. So we're in quadrant 1. So we're going to draw an angle in quadrant 1. And we draw a triangle. And r over x is 3 over 1, because secant theta is 3 over 1, so the radius would have to be 3, and then the x-coordinate is 1. Then we use the Pythagorean theorem to find the y value. So 1 squared plus y squared equals 3 squared. 1 plus y squared equals 9. Y squared equals 8. Y is the square root of 8, or 2 root 2. And so now I would find sine of theta, which is y over r, which which is 2 radical 2 over 3. And then tangent theta is y over x, which is 2 radical 2 over 1, or just 2 radical 2. And last example, same idea. Figure out which quadrant you're in. Tangent theta is negative, so that means y over x is less than 0. So either x or y is going to be negative. We're not sure which, but then we find out that sine of theta is positive, so y over r is greater than 0. That means y is positive, x must be negative. The quadrant where y is positive and x is negative is quadrant 2. So we're going to draw our terminating side in quadrant 2. And there's theta, but again, remember that we're using the reference angle to draw our triangle. So if tangent theta is negative 4 over 3, that negative sign really belongs with the x. So negative 3, here the y is 4. And then we have to find r. This will be a Pythagorean triple, 3, 4, 5. So I don't need to use Pythagorean theorem. And then I find cosecant theta, which is r over y. And that'll be 5 over 4. And cotangent theta, which is x over y, negative 3/4.